Concentration of ores. The process of removing earthly impurities from the ore is called concentration of ores or dressing of ores or benefaction of ores. Several methods are available for the concentration of the ore, but which method we are going to choose depends on the physical property of the ore and that of the impurity present in it, type of the metal, available facilities, and environmental factors. Now we are going to discuss some common methods of concentration of ores in detail. One of the method for concentration of ore is hydraulic washing. In hydraulic washing, pressure exerted by water is used to wash away the earthly impurities present in the ore. So principle behind this method is due to the difference in gravity between the gangue and the ore, that is gravity separation. In this method, we'll take the powdered ore on a slopy platform and stream of water will be made to pass through it. So what happens is that the lighter earthly impurities will get washed away along with the water and the heavier ore will be left behind. In the examination point of view, they may ask you the principle behind hydraulic washing, or they can ask in specific hematite ore or tin stone is concentrated by which process. Another method for the concentration of the ore is magnetic separation. This method is based on the difference in magnetic properties between the ore and the earthly impurities. Here, either the ore or the gangue must have a magnetic property and one should get attracted by a magnetic field. Then only such separations are carried out. Here, the powdered ore is taken on a conveyor belt which is made to roll over a magnetic roller. The magnetic ore will get attracted towards the magnet and it will fall on the region closer to the magnet, whereas non-magnetic impurities will fall away from the magnet due to centrifugal force. One of the important method for the concentration of sulfide ore is froth flotation method. In the examination point of view, this method is very important and you can very well expect a question from this topic. The principle behind this method is that the sulfide ore particles will get wetted, that is moistened by oil, whereas the gangue particles will get wetted by water. In this method, we'll take the powdered ore in water. To that, we will add the froth stabilizing agent, that is cresol or aniline, and we will add some amount of collectors to it. The role of froth stabilizing agent is to stabilize the froth form, and the role of collectors is to enhance the non-wettability of ore particles. That is, the ore particles should not get attached with the water. That is, it is to make them water repellent. The mixture containing powdered ore in water, froth stabilizing agent and collectors are mixed well and air is blown through this mixture to generate froth. The ore particles wetted by oil will rise to the surface along with the froth. Then this froth is skimmed off and dried to recover the concentrated ore. The gangue particles being moistened by water will settle down at the bottom. In the examination point of view, they may ask you what is the principle behind froth flotation method, or they may ask you what is the role of froth stabilizing agents in froth flotation process or collectors in froth flotation process. Next, we will discuss about role of depressants in froth flotation method. When a sulfide ore is having any other metal sulfide as impurity, then this depressant is added. For example, if you take galena ore, that is lead sulfide, it is having zinc sulfide as impurity. Then sodium cyanide is added as depressant. This sodium cyanide will form a complex with zinc sulfide, and it prevents that zinc sulfide to go along with the froth, and it allows only lead sulfide to go along with the froth. The last method to concentrate ore in our syllabus is leaching. In this method, the powdered ore is dissolved in a suitable solvent. So the metal present in the ore will be converted to a soluble salt or complex, while the gangue particles will remain insoluble. Thus, the ore and the gangue particles can be separated. We are going to discuss two examples of leaching process. One is alkali leaching and another one is cyanide leaching. In alkali leaching, bauxite ore, that is the ore of aluminium, is treated with sodium hydroxide at 473 to 523 Kelvin and at around 35 atmospheric pressure. So what will happen is this bauxite ore will get dissolved in sodium hydroxide to form sodium meta-aluminate, whereas the impurities such as titanium oxide and iron oxide will be left behind. Then this hot solution is filtered, cooled and diluted. Then the solution is neutralized by passing through carbon dioxide gas. So it will form solid alumina precipitate. Here if you take the sodium silicate, which is the impurity, will remain in the solution, whereas hydrated alumina will be formed as a precipitate. So this precipitate is filtered off and it is heated around 1670 Kelvin to get the pure alumina. Next we will discuss about cyanide leaching. This method is suitable to concentrate gold or silver ore. Here we will take the powdered gold or silver ore and we will treat it with sodium cyanide or potassium cyanide. So the gold ore or the silver ore will be converted to a soluble cyanide complex, whereas the impurities present in it will remain insoluble. Thus the ore can be separated from the gangue. The second step is that you have to get the pure metal from that ore. So what we will do is we will treat it with the highly reactive zinc metal. Zinc being highly reactive, it will displace the metal from its complex and we can extract the gold or silver. In the examination point of view, they may ask you what is the role of sodium cyanide in the extraction or the concentration of gold. Your answer will be it is a complexing agent. Next question is they may ask what is the role of zinc in the leaching of gold. Zinc displaces the metal from its complex. The equations involved in the leaching process are very important. So kindly practice well the balanced chemical equations.